Hello, everyone. Welcome to another binary episode of the Day Zero podcast. Before we get into the topics, as always, we'll cover the Spot the Vuln solution for this week. So, Z, I'll let you take that one away. Oh, Z, I think you might be having some audio issues. At least for me, you're not coming through.
Good catch. Yes, I was.
Okay.
Although, well, I was muted. Not so much a problem, just a mistake on my end. But yeah, so stepping away from the spot the vulns we've done over the past couple of weeks where we focus on the binary, I figure I'd toss in a little bit of a higher level problem. This is something I've seen this idea plenty, and we actually covered a npm file write leading to remote code execution during extracting of a package with this exact same vulnerability. The key issue here is over on line 4, you'll see it's, or on line 2, it's taking in a file name. We assume attacker controls that. Line 4, it's checking if it's an absolute file name, so it wants to write everything kind of within its own safe directory or relative to itself. So give rid of absolutes, give rid of path traversals, just assume that works. That is a very common place to see errors. And then it writes out the file name. So the issue being that it only removes the root of the path once. So if you have, say, // um, and it marks the root as being just that single slash, it'll remove that, and you'll still be left with an absolute path. Basically, the fundamental problem, or at least pattern that I would be looking for with this code, is anywhere where you see it kind of stripping a blacklist, but it only does so once. You kind of want to do that recursively to repeat it with the generated string to make sure removing text doesn't create kind of the same problem again. So, I mean, you could see similar issues when it comes to like cross-site scripting or really anything else. Yeah, just kind of a higher level and hopefully easier to understand issue this week.
Yeah, we had a few people who guessed the solution pretty quickly. I think somebody got it in chat, like within a couple minutes of our bounty episode yesterday, and some people got it in our Discord too. So, yeah, I mean, a bit of a higher level issue for a change, but um, one that's been seen before, and we
Yeah.
covered it in the npm set of issues yesterday. So, all right, let's move into our topics. So, Z, you noticed an interesting CTF going on, ChaffCTF. I think you're the one that initially brought this to my attention too. We had a little bit of discussion in the Day Zero Discord. I saw you reaching out, seeing if anyone had really tried to play around with it too much. Seems it's not as popular as maybe we were thinking it might be. There's still only one solution
Yeah,
on
it looks like
CTF,
one
so
team has solved it. Even though you'll see the 2 dots here, that's an extra 10 points because they were also first blood, not an actual like second solve. Yeah, this was CTF. They did extend it, so it's supposed to just run over the weekend. And they extended it out through for the rest of the week. There is kind of a catch with this. It's ChaffCTF, and what they were hoping to test with this was this whole concept of having chaff bugs in software and whether or not that actually makes it more difficult to exploit or take advantage or like find actual issues. So what are chaff bugs? They have an entire paper on this and how they introduce them, going into reasonable depth. The gist of it is chaff bugs are just bugs that should not be exploitable, but will be found and be difficult or take time to triage by attackers. So you can imagine, you toss it into a fuzzer, you get a ton of hits, and like none of them are exploitable. Like they're intentionally designed to mislead you. That's the gist of what the bugs are. They go into their actual process of it using they take advantage of a tech that we've actually talked about before called Lava for injecting bugs. And the idea with Lava was for testing fuzzers to make sure they can find bugs. They obviously repurpose it a little bit to inject bugs and then make sure they're safe bugs, but they kind of build off that a little bit. The idea feels intuitive. Yes, more bugs can definitely hinder the whole exploitation process. One, just having to triage more. Two, you waste time triaging bad bugs or bugs that aren't interesting. So it seems obvious that it would have an impact. I should mention, so with the CTF, every team gets a random selection of chaffed and or gets a random selection of challenges that are chaffed and some that are unchaffed. So that way they can kind of compare how quickly, or could have compared had they had more people trying it, how quickly the chaffed ones are solved versus the unchaffed challenges. Um, yeah, I mean, it feels a little bit intuitive that yes, it would cause problems, and it also feels like one of those things that um I'm just trying to think of how to kind of phrase this, but it feels like one of those things that if this were to gain widespread adoption, it would get recognized pretty quickly. Like we would start seeing automated patterns in how they're injecting bugs because these are automatically being entered. They do put a lot of effort into keeping them, or kind of requiring manual triage, but they don't really put a lot of effort into making sure they couldn't be pattern matched. So that's
You're
kind of
mostly
my
saying
feeling.
you're mostly saying here that attackers could pretty easily like evolve and adapt to it if it became like an actual problem.
Yeah, that's kind of my feeling so I had some discussions on other discords about kind of how we might be able to detect it without actually wanting to waste too much of my weekend actually trying to do it. But my feeling is, so it'll store like attacker input into global memory and then kind of pull it out of nowhere and use it for the actual attack. And I feel like that global access in some programs, which will use more like perhaps heap based memory or something like that, will feel a little bit off. It might be a point of detection. Also, just the types of bugs being injected, although they do some interesting work with that. Like, they'll allow you to overflow, like, they'll give you stack and heap overflows, but make sure you can't do anything with it. So you might be able to overflow into a variable that in theory is unused, but then they add code to kind of use that variable and do random things with it. uh, just so you have to actually go and reverse engineer the binary to figure out how it's being used, but it's not used for anything practical. Uh, but then you could overflow on the heap, get a instruction pointer control, but they make sure the only values that they would do that with or allow you to do that with are values that will point to unmapped memory. So they kind of create challenges there, but they create somewhat realistic looking bugs.
It kind of teases you into thinking like, okay, I have instruction pointer control. I'm at the end game now. Whereas it's just kind of teasing you with that and not letting you actually take it anywhere. Which is kind of cool as a concept, I must say. Though I don't really know that it's best used in something like a CTF environment.
No, but
Um,
I get what they're going for with trying to fix this, or
for
sorry,
sure,
trying to test it to see if it actually happens. If
trying to
if
collect
their
information. Yeah,
yeah, if their assumption's correct, like that is completely valid. And I don't think it's a bad idea. Where I personally think they kind of went wrong though is just in the fact that the challenges that they created. I guess I have to log in to do it, but none when I'm going to go play CTF, like I'm still looking to have fun, and even with something like this, I'm yes, I understand having the chaff bugs will be frustrating, but I'm still looking to, enjoy myself playing these challenges, looking for use a more cliche term, intellectually satisfying challenges, even if there are these chaff bugs in there. Like the chaff bugs are part of it. And when I went to go look, it just felt really poorly designed. Like there were no descriptions for their challenges. Just here's a 100 kilobyte binary. Here's 150 kilobyte binary. Have at it. Um, you did know a little bit from the name, but the name was let's see if I've still got a couple copies here. But the names just indicated essentially some type of parser was being used. There's like a zip challenge, reg file, um, MP3 was another one. there were various challenges of that sort that just seemed like they were going to be parser issues, so something you'd probably want to fuzz even on like a normal CTF. Um, I don't know. None of them really just looked even interesting or worth putting much time into. I don't know what their background is for actually doing challenge design, but I feel like that could have been part of it.
Yeah. So, I mean, essentially what they're doing here is like a red herring injector. And we've talked a little bit about like challenge design in the context of previous CTS. The idea of injecting red herrings is not really new. But the thing is the challenge at base has to be good for people to still want to engage with it and enjoy it. If the challenge isn't good, then adding more annoyances on top of that just compounds it. It's just like people just don't want to do it, right?
Yeah, it's like it's an interesting challenge, but I still want to enjoy it. Yeah, I think there's something like 500 some team, well, is this teams still? Yeah, 500 and some teams. You can have one person teams. So I'm just going to assume, 500 or so people registered. That said, I imagine a lot of people just registered to very briefly check it out, not to play. Their Discord was very inactive. It didn't seem like anybody was actually playing it. So I mean, if you want to get some of the prizes, because they are giving away money for this, second place is $100 Amazon gift card and ChaffCTF t-shirts, and third place is just a shirt. You could probably still get in there on an unchaffed challenge since they still have this up for another week. I have to imagine it's just a case of not many people are looking at it.
So another thing I wanted to call out was I remember you mentioning you were looking at one of the challenges, and on their homepage they say there will be 6 challenges of roughly equal difficulty, and each team will get 3 chaff and 3 unchaffed challenges. But I remember you saying that didn't hold true for the challenge you looked at. You said you had like 4 chafe challenges, I think.
Yeah, actually,
Um,
when I registered, 4 of mine were chaffed. But that's probably it. Probably just chooses them like at random. So in theory, you should be getting 3.
like
Um,
3 on average. Yeah.
yeah, that's my guess. I had 4 of them, but I mean, I didn't really play them anyhow, so it doesn't matter.
Well, the reason I point that out is just because it may be too that they had some bugs in how they were giving the
Oh,
challenges to
maybe,
teams.
but
So that could also explain why there might not be as many solves. That's just speculation, but given that it doesn't line up with what they said on the rules page, that just kind of got me thinking.
yeah, it was a
But
little bit surprising, like that even happened in the first place.
yeah, so yeah, that's still ongoing. If somebody wants something to do and they're bored, maybe they can check that out. Kind of like you though, I don't know if I will, even though it is still ongoing, just because like um the whole idea of introducing these chafe bugs is to be a time waster, and I just don't really feel like putting time into something like that.
Yeah.
But I respect what they're trying to do for sure. It makes sense to try to test the effectiveness of chase bugs against attackers, which is what they outline as their goal in their homepage. So yeah,
And actually,
interesting
yeah, I
concept
did.
though, and interesting to see it introduced in a CTF like that.
I did just remember the password I used to register here, so at least for those watching, you can kind of see how they've named their challenges. Kind of just gives an idea that these are probably parser related, but they don't have any descriptions for anything.
Yeah, which challenge was the one that was solved actually? I don't think we ever looked at that, did we?
That looks like we don't actually find that information. Solve percent, solves over time. Yeah, it doesn't actually indicate what the challenge was.
That's really strange. I thought CTFD
Oh,
usually
elf
had that
parser.
information.
Sorry,
Okay.
it is there. It's just slower.
Okay. All right. So that's interesting that it was that challenge because I was thinking it might have been like the zip challenge where it was the first one, but it's not. Anyway, yeah, just an interesting application of chafe bugs and a good opportunity to talk about them a little bit.
Yeah, like
Um,
I'm genuinely curious. Like, I kind of wish this would have worked out, just to like see some actual results of the chaff bugs. Like, I hope we don't see them. To be honest, like, I hope people don't just start adding in. It just ends up being an extra hassle, an extra layer of work.
it feels like it would hurt defenders more than attackers, honestly. Like if you were doing like a security assessment against something that had these bugs in it, you're probably just going to become annoyed and move on to something else. Whereas a determined adversary is just going to find them a bit annoying and find a way around them. Like it doesn't. It kind of falls into that defense in depth type category where it's like okay, it might work a little bit, or it might deter script kiddies or people who just don't want to deal with that kind of mitigation, or if you can call it mitigation.
Yeah.
But I think its effectiveness just it's not really worth the hindrance
I
that it
think
could offer to people who are useful and defensive.
as soon as it gets widespread, it'll be a lot easier to kind of have the investment just to universally defeat those implementation. And I guess I do have to walk back one statement there. I do apparently only have 3 Chaffed challenges here. I could have sworn looking at it the other day I had 4. Maybe they fixed that. Not sure, but looking at it right now, I only have 3, so maybe that wasn't a bug. Out of chat though, some dude 456, can they guarantee the chat bugs are exploitable? No, they tried to guarantee that they are non-exploitable though. Um,
But I think
the
that
other
is
way.
one of the things the CTF was trying to prove as well.
Yeah, that was
Was
something that they mentioned, I believe, on the rules page, perhaps, that they'll be collecting the information. Yeah, to see the traffic sent to the challenge server to see if any of the chaff bugs were actually exploited. But they take a number of steps to try and ensure that they're not.
yeah. So again, like you said, it would have been cool to see some of the results coming out of that because that is one of the questions that would have been answered. But where people didn't really play it much, I don't think they're going to get too much useful data out of that.
No, unfortunately.
Yeah. All right. So there was a 0-day dropped on Android's Ion Allocator, which was very interesting this week. It's not very often that Android O days get dropped like that. Um, there's some interesting discussion to be had around that, but we'll get into the actual issue first. In certain versions of the Ion Allocator, including some of the upstream kernels 3.14 to 5.9, 4.9, 4.14, and 4.19 in the Android common kernels, and a Pixel kernel as well as a Samsung kernel, they expose an ioctl in the Ion driver called DMA buff ioctl sync, which can be used to call DMA buff end CPU access and begin CPU access an arbitrary amount of times, which is notable because one of the things that function does is keep an internal reference count on the allocated ion buffer. So end CPU access will decrement it, begin CPU access will increment it. So by abusing that ability to arbitrarily call um, something that can decrement a ref count, you have a ref count bug. You can cause the UAF situation on the ion buffer. So the vulnerability is pretty straightforward, which is interesting as far as Android issues go. Usually, when you're talking about these more universal type Android bugs, they're pretty complex by nature because they have to be because mobile is so cutthroat. But this bug is fairly straightforward. It is made a little bit more complicated by the fact that the Android ecosystem is an absolute mess and it's fragmented to hell. So even though this vulnerability does exist on the upstream and the Android common kernels, there's a lot of phones uh, and and vendors that modify the Ion driver or might use a different version of it. So it's not exactly a universal bug, even though technically it should be. Um, and that's just a side effect of how insane the Android ecosystem is with keeping the code consistent. It's been an issue for years. Google is trying to uh, improve the situation by introducing things like the common kernel, but it's going to take a lot of time, I think, before that situation is fully
Yeah, it's
fixed.
going to take a lot of time, but I mean, they have the power to kind of drive some of that adoption. Um, it's a positive move on their part to start trying to centralize some of that out to make updates a lot easier and a lot more doable.
Yeah. So, yeah, we'll get into some of the meta discussion. This was reported to the Android security team on June 24th. But while Google technically accepted it and marked it as a high severity rating, the issue wasn't fixed, and Google refused to explicitly grant or deny permission to disclose in accordance with their own disclosure policy. Though they did request to read the draft before publication to suggest feedback. So they were they were working with the researchers a little bit here. But the bottom line is the issue didn't get fixed. So in accordance with P0's own policies, um, TASZK released this write up. What made this a little bit tricky from Google's perspective, to be a little bit charitable here, is um, they also TASZK pointed out that a manifestation of this bug was reported in July of 2020 and marked fixed in January 2021's bulletin. And this was what they thought was a UAF in the KGSL driver. The problem was, though, it wasn't fully root caused. Um, and the root cause was actually inside of the ion allocator itself. So because it wasn't fully root caused properly, that bug was left unfixed. It seems a little weird to me that Google wouldn't want to fix this issue or wouldn't even really offer some good correspondence with them with a bug like this. Um,
It
because while it
does.
doesn't affect every phone, it does affect quite a few, and it affects their own code base. So it's really strange.
Yeah, this is a very, I guess, blatant bug that exists. And I'm wondering if there's, some sort of weird dependency that makes it hard to fix, but I can't really see what that would be. Because worst case scenario, you're just probably add some checks so the function can't actually decrement it down to zero, having like a secondary counter. So that you can only decrement what you've incremented using the CPU access. That seems to be a somewhat straightforward solution here. Not the ideal solution, but like if they absolutely need to maintain this functionality, that kind of feels like maybe something they could do is tracking something like that. Um, that said, yeah, I really don't like. I can't even fathom a reason why Google wasn't on fixing this one. Like, I genuinely like. Usually, I have some charitable explanation or something. I genuinely don't know with this one.
It's strange for sure. I did want to pull out a few things from chat. Um, Dilbert Marker mentioned it does depend on the driver using the ion allocations. It's not 100% straightforward. So yeah, that is fair to point out. And somebody else asked what the ion allocator is. So yeah, ion was Google's custom rolled memory solution for solving the issue of fragmentation. And because of that, it uses Vmalloc, which for those who aren't familiar with the Linux API, it basically guarantees contiguous memory. That's how it's a little bit different from Kmalloc in that respect. So it would be a little bit tricky to take advantage of this. It's not like a straightforward, UAF and some Kmalloc cache. That said, I think this would be it still wouldn't be too difficult to take advantage of, because there are some various vendor drivers that would use the ion allocator. Um, I haven't gone looking personally for how you would like exploit this issue, but I don't
Yeah,
imagine it would be super difficult.
yeah. No, the exploitation is actually a little bit interesting, just because of that aspect that a malicious user can pause this free, but they still need to kind of get a use somewhere else after they've allocated it or had it allocated. And
Yeah,
so
you're
that
not
that
fully in
does
control.
create an interesting exploitation, but like the bug itself seems like something they should have been able to patch like reasonably easily. That said, I do have to say, like, I'm backseating with that. I'm or armchair fixing, which oftentimes things are a lot more complex than they seem on the surface.
Armchair developer. Yeah.
Yeah.
Um, yeah, I mean, so it is interesting as far as kernel goes, because generally with the kernel heap and whatnot, um, one of the benefits of being a kernel attacker is you have a lot of influence over the kernel heap as a user space process. It seems a little bit unintuitive, but because of the amount of syscalls and just the amount of things you can exert a lot of influence on the kernel heap. But where this is a bit of a separate area, where it's using Vmalloc, you kind of lose that level of control. So that's where the exploitation does get more difficult. This is not a straightforward UAF, but somebody will find a way to take advantage of it, especially given that we're talking about Android. Um, so yeah, but that is a good thing to point out. Like it is a little bit different from what you typically see with kernel UAFs. So um, yeah, but not too much more to say there. Relatively straightforward as far as Android issues go. Continuing with kernel issues, we have one from Chompy up next, a vulnerability in IOU ring. This bug was kind of strange in nature and the way that it worked. It's kind of a case of mixing up kernel and userland pointers and operating on them indiscriminately. Um, so in a way, it's kind of like a type confusion, um, or there's kind of that element to it. I don't know if you'd want to call it that.
Yeah, I wouldn't
Um,
really call it that just because of what it like. I mean, it's still just acting on the buffers. It feels different than what we would traditionally talk about as a type confusion. But I'm not exactly sure what I would call this one.
it's hard
It's
to
also
classify.
yeah, it's also kind of a weird primitive that you gain. Like in theory, you can kind of just treat it as a primitive for freeing arbitrary kernel buffers. In practice, kind of what's going on though is a free of adjacent buffers. So like you can free the next buffer in memory, or you can go beyond that too. You increment up to it, but it's just a really weird primitive to have in my mind.
Yeah, for sure. So IOU ring is like this IO subsystem that's been designed for performant IO. It's pretty new. I think it was introduced in 5.4. I'm not certain on the minor version, but it was definitely 5 dot something and higher.
No,
Um,
5.4. Yep.
okay, so it was 5.4. Um,
Or at least to
yeah, so
Android, I guess.
yeah. So IOU ring provides this interface for being able to create and manage buffers. And if a file implements a read iter operation or callback, um, this loop RW iter function from the IOU ring driver is called to do iterative read and writes. Under normal circumstances, the pointer it operates on will be a userland buffer, and for each iteration, it'll increment the pointer by the size of the read or write. Problem is, it's possible that that pointer gets set up as a kernel controlled buffer, which you can do by pre-selecting a buffer with the IO ring op provide buffers command. And when that happens, later on when the request is completed, it doesn't want to leak memory, so that kernel controlled buffer gets freed. Um, the problem is, though, by giving the user influence over the kernel pointer in that RW iteration or read write iteration, users can arbitrarily free the adjacent buffers, as Z was saying, at a controlled offset. So it's a very cool bug. It would be a little bit tricky to exploit, though, because I did do a bit of diving into the code. The kernel buffer in question will be allocated in the Kmalloc 32 cache, meaning to set up a good UAF, you'd need a target object with useful pointers and a reallocation gadget in a cache that's really small. It's gonna have to be 32 or 31 bytes or less. So that presents its own challenges. The other thing is Kmalloc 32 will be a heavily used cache. Generally speaking, the smaller the cache, the more activity it's going to have in the kernel, the more noise it's going to have, which means that it's going to be trickier to hit your reallocation. You're going to be racing a lot more things to get control over that pointer. Um, that said, though, it's totally doable. I actually asked Chompy about this on Twitter, and she pointed out the IO buffer object itself fits the criteria for being in the UAFable cache. Um, and while reallocation would be difficult, you could do it. It just might not be super stable, or you'd have to do some tricks to make it stable. So, yeah, I have no doubt this is exploitable. To my knowledge, I haven't seen an exploit public for this yet or anything. According to the report on OpenWall, though, Chompy will report on some details on exploitation at some future point. So um, I'm looking forward to that. This would be an interesting bug to look at, though. If you're looking to get into kernel exploitation or just looking to understand kernel vulnerabilities, this seems like one of those perfect test cases to go and try to root cause it, figure out everything about what's going on, and try to write an exploit for it. I think this would be a good application for that. I don't know how easily you could take it past all modern mitigations like SMAP and whatnot. But if you're just looking for something to do, you don't have to care about that right away. So yeah, I mean, cool bug. I think this could it would be a really cool exploit too. So I'm looking forward to the details coming out on that.
Yeah, like I said off the start, like it's a really interesting primitive to gain.
Yeah, it kind of follows into that arbitrary free class of issues, which
Yeah, like you can
you don't
kind
get
of
to see
treat
too
it that
often.
way.
Yeah. Um, some dude asked what the intent of providing the kernel buffers is. So I don't know for sure. The documentation on IOU ring is not very good. There's also a lot of movement. The driver has changed a lot in the minor kernel revisions. My immediate guess though is it's a performance thing. It's got to be something, or it's it's an issue where you want the memory to be managed by the kernel because you don't want it getting paged out or something in user space. Something to that extent, I would imagine, because otherwise it wouldn't really make sense to provide that capability. I kind of agree. Um, I think they should have had different paths to handle userland and kernel pointers. That seems like a recipe for disaster operating on them in the same way. But yeah, as to
Yeah,
the
and
exact intent of implementing that operation, I can't speak to
yeah,
exactly
unfortunately,
why they added that.
I've spent some time looking at IOU ring before, but I looked at it in 5.4. And this was not yet in 5.4. This came in sometime around 5.7, 5.8. So I haven't actually used that to play around with it. That said, my AOCAT asks, what is a primitive? Which is a really good question. I don't know how much time we want to spend there, but primitive just being like um if are you familiar with the idea of ROP, like ROP chains? If you are, like you can kind of think of primitives in a similar sense to gadgets. They'd be a little bit more complex in your gadget. You might use a few gadgets that will give you some sort of basic generic primitive. I think arbitrary read, arbitrary write would be two different primitives, or constrained read and write. Um,
I like to
as
classify a primitive as a building block. It's a building block you use to get to your end goal. So memory corruption is like or some form of memory corruption, like a UAF or an out of bounds write, is your initial primitive. Then you're trying to use that to get a better primitive, like a relative read write or something. Then maybe an arbitrary read write, and then code execution. Code execution is the typical like end goal. That said, you don't need it all the time necessarily. You could end off with like an arbitrary read write and do like a data oriented attack, but yeah, the way I like to think of primitives is like building blocks, and you're just building to get to what you want.
Yeah, I just linked in chat, and I guess I'll bring it up so it comes in our notes too. I had this as a shout out in one of our last episodes before the last break. And this was a talk by Thomas Dillian. And he talks about this entire concept of weird machines, but that includes primitives. Maybe this is going to go a little bit deeper than what you'd want, but it's a really good talk that tries to capture how modern like exploit developers are thinking about exploitation and exploitability of something. And that is involves like breaking it down into these more fundamental concepts of primitives, and talking about the primitives you gain and chaining those together as your building blocks for something. So I thought it was a really good talk. Something a little bit simpler. I think I found out about this talk. It was through a Project Zero post. I'll see if I can find it really quickly, but otherwise,
Yeah, so while you're trying to find that, I'll just mention Dilbert from chat also mentioned the kernel network subsystem also has pointers that can switch between user and kernel space. Yeah, I mean it's not super surprising. The networking subsystem does some really wild stuff. Probably the biggest source of bugs on the kernel, honestly. At least from what I've seen. Um, And Sarky mentioned, is this Chompy's Vuln? Yeah, this was Chompy's report in IO Earring. So yeah, I mean, very cool bug, and I'll be interested to see if and when exploitation details come out. Z, did you manage to find it? I see you had
No,
something
I
up on
I
screen.
found one, but it wasn't the post I'm thinking of. If you hit me on Discord, I'll find the link for you.
Yeah, okay, fair enough. All right, so we'll move into our Parallels desktop escape. We have Parallels in the
Yet
news again
again.
this week. Yeah, I know, back to back. This is by Ben McBride. This post gives a really nice introspection into security research and methodology. A lot of the posts we cover, basically, like the format they follow is they give some background information, then they cover the issue. This one reads almost like a diary of a night by night basis of finding and exploiting an issue. So it gives a lot of insight on the angles that you don't really see too often, especially if you're like newer to it. Some of the posts can make it seem like you just logged in. It's kind of like Hollywood hacking. You just like, oh, I found the issue in a couple seconds and I got an exploit next minute. This post kind of shows all the steps um, that are good to take when doing like a security assessment and kind of gives some insight there. So it's very cool.
Yeah, I
Um,
really enjoyed the writing style on this one. Like this is just a very well written write up for any sort of. I mean, it's a hypervisor bug, but like just in general, really solid write up. Really cool to see a little bit of just like, hey, I did this dumb fuzzing. I didn't think it would work, but it did. And getting some of that insight. And this goes right through discovery, through his wife going into labor and having a kid, through getting code execution and like the actual exploitation.
yeah. So the initial reason he was doing this was for Pwn to own. The initial testing and exploit was written on an older version of macOS, which we'll get into a little bit later because it did make the exploit a bit more complex. But yeah, we'll start off with the first few nights he documented and like the methodology and the initial finding of the bug. So the first 3 nights were spent doing Vuln research, doing some initial setup and getting a build environment going, writing some like quick dumb fuzzers for fuzzing IO ports and whatnot. Um, got a lot of assert type crashes, which initially didn't seem interesting, because if an assert is firing off, that's not really going to give you any useful memory corruption. It's just going to crash. Night 3, he then moved on to fuzzing memory mapped IO, triggered a few crashes again. In this case, though, when looking at the crash log, one of the asserts ended up being a page fault in the hypervisor, which meant that the memory corruption likely happened higher up in the stack trace, meaning it could potentially be an exploitable issue. He also found crashes in different spots with different register contexts that had kind of the same nature to them. So that looked promising for it being an exploitable issue. After doing some root causing, he discovered it was in the VirtIO VGA device in the common CFG settings MMIO region. One of the MMIO registers, being the driver feature select register, ends up getting used as an index into an array to write into a guest controlled value into um, some array that's mapped, and that's through the PCI VirtIO write MM function. And that driver select register, feature select register, wasn't bounce checked. So, speculatively, it was going into. Sorry, I'm saying speculatively as in I'm speculating here. It was indexing into a table of features, um, but because they didn't end up checking that index, you could just index into adjacent tables or wherever else in memory. So that gave you like a relative read write because that issue also existed in the read path, the read mm function. Um, so having a relative out of bounds read write like that, like having both of them, is a very powerful primitive. Generally, in any modern piece of software, it's pretty easy to take that to code execution. Um, and later on, after a few personal days, where he mentions his wife went into labor, which is awesome, he used that read write primitive to install a port IO handler in an unused address range to install a handler that would grant code execution. So that all worked on the Parallels desktop version he was investigating, which was on the older version of macOS. Um, Pwn to own, though, required a fully updated macOS running Big Sur, which required some adjustments in the exploit strategy due to some code refactoring and some mitigations. Notably, in Big Sur, Parallels doesn't control the hypervisor anymore. So instead, that code was migrated to a host user mode library called libmonitor. The vulnerability still existed there, but because it's in user mode, there were more mitigations that could easily be applied on it, like ASLR and whatnot. So we had to get around that. To do that, he used a relative read 24 bytes away from to get in the address of another object in the common section, which allowed him to get the slide and thus the base address of the library. Because assumingly it was a static object in the binary. Um, so yeah, he was able to use that, then revisit the old exploit strategy, create the arbitrary read write, create the port handler using that arb read write, and override an entry in the dynamic linker cache to get code execution. So yeah, I mean the exploit strategy was fairly standard, I guess, when you're talking about going from a read write to code execution. That's generally like one of the more commonly used strategies. Um, but yeah, I mean, just a really well written post though, talking about the vulnerability and how it was exploited.
Yeah,
Um,
that was really the thing that stood out to me, was just how well written this post was in terms of being able to follow exactly what the vulnerability is without needing to get too bogged down in and he includes a lot of technical information for like parallels and how it was working, but it didn't feel like you were being bogged down by all this background. Like, okay, this part matters now, so this is what happened, like where he's talking about here Spectre just covered how he got the code execution, or got the actual control flow hijack, and then he goes into like the SMB right gadget that he uses, or that he points to as his way of calling like an arbitrary function, calling system by overriding a couple pointers at that function. And covering that, like covering a lot of the details, uh, concisely. I was genuinely like, I finished reading this and was surprised by how well done it was. I keep repeating myself. Um, that said, I mean, he says at the end there, Uh, I really enjoyed the process and was reminded of a few things, such as just try. Not all pwn-to-own targets require novel vulnerability finding and exploitation techniques. Is kind of what I'm seeing in chat right now, talking about the 8 days to find a bug and write an exploit. So it's worth noting it was 8 days to the first part. He talks about night 8 being got shellcode running in the hypervisor. That's where he was basically just able to map the read writable, or yeah, read writable page, execute it. Um, that wasn't including the Big Sur time. So the actual exploit did take more than just the 8 days. We're not given a timeline on that, so I will just assume that actually did happen during the 8th night. Um, Not really. I assume it took longer than that. But they make a good point. Like, not all Pwn targets actually require the novel vulnerability hunting. Like, this is an example of just using dumb fuzzing and ending up in the right place.
Especially in
And
the area of virtualization and hypervisors, it seems that dumb fuzzing is really effective right now.
yeah, it feels like, hypervisors, at least what we've seen with some parallel stuff, with some VMware issues, is that they're lagging a little bit behind some of the other standards, like you might see even in operating system and of course userland. So like you've still got a little bit of time there, but there is a higher level of entry in understanding and like documentation around them.
Lagging
Um
behind maybe a bit. The other thing is too, though, it has an entirely new area of like vectors. So when you're dealing with things like memory mapped IO and uh, and like these memory mapped registers and stuff, it's not an input that's really explored as much in other targets. It's I feel like it's harder to model the input for a hypervisor or anything that's
Fair, yeah.
dealing with virtualization. So that's the other thing too that makes it more ripe for finding vulnerabilities with this dumb fuzzing. It's just there are so many potential entry points.
Yeah, like I say that and just using dumb fuzzing, but at the same time, we haven't covered, as far as I'm aware, any Hyper-V exploits on this episode. Or not on this on this podcast. Um and that's one area that I'm actually wanting to kind of get into, is the Hyper-V exploitation. So the lack there makes think, maybe it is just VMware has some bad code and parallels. Because that is generally who we see getting attacked, but oh no, it feels like at least those two have been a little bit behind.
So, I mean, part of the thing there is Hyper-V is used a lot by Microsoft, not just for providing like desktop virtualization for customers for like Windows 10 Pro users and whatnot. It's also used in their secure boot or their virtualization based security stuff for Windows. They also use it
Cloud.
in
Cloud is
they
a
use it
huge
in the
thing.
cloud.
Like
Yeah,
that's
the cloud is their major thing. So Hyper-V is used a lot more in more security aware contexts, I think, which is probably why it seems so much more secure than some of the other hypervisors like VMware.
yeah, I'm just
Um,
surprised like there have been, as far as I can tell, like no write-ups on it. Um like that's because we've covered a lot of vulnerabilities in a lot of software over the past couple years doing the podcast.
yeah, we've covered some Hyper-V research, but those were mostly done by researchers at MSRC. So I don't know if that really counts as like a external report.
Yeah,
And yeah,
I'm
Hyper-V
just
is also used on Xbox. Yeah, Xbox's security is absolutely bananas. They have definitely taken the cake in terms of mitigations and isolation on the system. Um, Hacking an Xbox One is not even close to trying to hack a PS4. PS4 is so much easier. So yeah, that's good to point out too.
yeah, I guess we could probably move on. Um unless
Yeah,
there's
we'll get
anything more shall I
into
say there.
yeah, no, that's good. We can move into our last research topic of the episode, which is Igor. So, we were talking there a little bit about fuzzing, and this paper focuses on deduplicating crashes and making root causing and measurement of fuzzing easier by collating bugs with the same underlying root cause together. It sounds simple, but it's not a trivial problem to solve in practice. It's been a nuisance of fuzzing forever, at least on the targets that I've looked at. We've seen some papers before that have talked about this problem. I think it was one of the central premises behind Hong Fuzz. Um, an existing solution that's been around for this is the idea of crash bucketing, where it'll try to group together reports based on the same like root cause, and to do that, it'll use like hashes of the stack trace, crash locations, coverage profiling, like comparing the control flow graphs, or some other like heuristic techniques like that. But none of them are really perfect, right? They point out here like crash locations are very coarse grained, and it's easy to trigger a bug in different ways. So it's both over and under reports the amount of bugs or the amount of crashes for a single bug. Um, Coverage profiling is the another way that it's like that existing fuzzers have tried to tackle it by checking the control flow graph. Problem there is slight modifications in the path, like a something with the OS or anything, could inflate the bug count because it could throw off that hash. According to the paper, with what they've looked at, it's usually conflated by an estimate of like 2 to 3 times as much. Um, Stack hashes are the other one, being they're a bit better than coverage profiling when it comes to overreporting, but it kind of falls into that bucket of crash locations where it's too coarse grained. So, what the researchers and authors of the paper angled for was a solution that utilized some of the elements from those past solutions, but ultimately ended up being more effective at grouping crashes to a given root cause. So, that led to two main things coming out of the paper being their coverage reduction fuzzer to minimize test cases, and a metric for crash grouping based on control flow graphs. And that's using the Westphal-Lehman subtree kernel algorithm, which, from what I can gather, just does some heuristics comparing nodes to neighbor nodes. I don't really, I'm not really a major in data structures and algorithms and mathematics, but so that's a very simplified and surface level version of what I was able to read into it. I don't know if you can offer any more on that, Z.
No, I really can't, even having done the comp sci degree. It's unfamiliar to me also, but I
Yeah,
mean
I think that surface level
effectively
understanding is good enough to understand the paper, though.
Yeah, effectively, I mean, they're kind of doing their own little fuzzing to minimize the proof of concepts and then going with the control flow graph. The exact details are or the exact algorithm choice there, I don't think is what's consequential here.
Yeah. So they classify all of this under Igor, which they have as a public repository, which also has some evaluation scripts and whatnot. I am going to bring that up on stream just so we can have it in the description of the video and whatnot for people who want to check it out. So they have a bunch of their code on there. They talk about some of the key goals of their approach and how they targeted them. One of the big key goals they had was scalability, because doing this kind of triaging and crash bucketing can become difficult when you're trying to minimize and group a lot of crashes. Like, I think in their test case, or in their benchmarking, they were using like hundreds and thousands of crashes. So, that's quite a lot to manage. So they talk about a two-stage pre-processing phase they use, which samples the corpus to reduce the number of analyzed test cases. They basically use like AFL tmin as an initial minimalization tool, and then they pass it off to Igor, which does further minimization and grouping. Toward the sixth page of the report, or of the write up rather, they start to talk about the design of Igor. I'll point out a few points I found interesting. They have their high level like algorithm pseudocode there under algorithm one. um, Basically, what it's doing is it continuously processes seeds for a given test case and then evaluates a score for them based on the execution time and the amount of edges. The fewer the edges, the higher the score. Just trying to simplify the test case down, basically. They then try to filter to get higher and higher scoring test cases. There's some other checks there too, like if it's worth fuzzing based on the score and if it has a smaller bitmap size for the input, some other stuff. But that's the main idea, is it's continuously trying to get better and better test cases that have reduced complexity in the execution trace. By doing that, they have a much smaller likelihood of the new test case triggering a different bug, which they can then use for checking for similarities and grouping them together. In terms of results, they measured against the Magma benchmark and the Moonlight dataset, which contains 52 CVEs that belong to 14 programs. And as I said earlier, it contains, they said, 254,000, more than 254,000 crashing POCs that map to 39 unique bugs. Um, they then manually labeled and constructed a ground truth set to compare Igor to existing solutions. They have a table of results on the 10th page where they cover the various programs on the data set, and they show a 15-minute and 30-minute cutoff time, comparing Igor to Top Frame, BFF5, Hong Fuzz, and AFL Collect. The metrics they focus on there are the accuracy of clustering, which is measured with purity, inverse purity, and S-score. Purity being something that penalizes noise in a cluster but doesn't reward grouping items from the same category. Inverse purity being the opposite. It rewards grouping items in the same category but doesn't penalize the noise. And then they have the S score, which I think is their primary thing they look at, um, which is like the mean of the precision and the recall, or in other words, how many times something was grouped together compared to how many times it should have been grouped together, which I think is kind of an important metric because that's something that's been missed in some of the papers we've covered before. It's hard to really calculate how many times something should have been hit compared to how many times it was hit. And that's something that's often skipped. So I thought that was worth pointing out. They found Igor had the highest F score and purity numbers in most programs. The only notable outlier there was PDF Top M. So the results look pretty promising. They do have some limitations though, with the Igor fuzz. For one thing, it requires substantial computing resources compared to other methods like stack hashing. They argue that it's worth it because the overhead is roughly 0.3%, and they say that the trade-off of saving like a dev team a lot of time is worth that relatively minor performance hit.
Yeah, and I
Um,
mean, I don't know how you feel about that. I would say I have to generally agree that it seems like the trade-off would be worth it.
I would agree as well.
I think one of the ways of thinking about it is, after you fuzz for a while, like this could also be part of continuous fuzzing, but you fuzz for a while, you get a ton of crashes, and then run Igor on top of that once you're kind of done, or as you're kind of winding up the fuzzing campaign. It kind of just makes sense to be able to toss, like especially Like they're talking about the computing power, but they're also talking about the time frames of like 15 minutes and 30 minutes,
Yeah,
which
is
is
not very
not,
much when
yeah,
you're
is
talking
not
about fuzzing
much.
time.
No, I mean, you're usually running a campaign for much longer than that. So, I mean, even at higher computing power than, because a lot of the other solutions and the normal solutions are taking very simple solutions, like, oh, just bucketing the crashes there is a very kind of simple solution. It's not some that takes a lot of computing power. So, yes, of course, it's going to take more. It's basically saying, like, we should actually start considering doing that extra processing here.
Yeah, that's one of their primary arguments. Um, the other two things they list in the limitation section is sometimes the scoring method they use to determine the number of clusters might not distinguish properly on a first pass. So it might need a second pass to get a more reasonable set of clusters. Um, Finally, in edge cases, like when there's only one bug, they say that intra-class differences get confused as interclass differences, which then might divide the input samples into a large amount of clusters. It can kind of lead to this explosion in clusters, which they try to detect for by comparing it against the number of groups that AFL Collect provides. And then if it's greater than that, they just fall back on AFL Collect if they need to. So it's not a huge problem. It is just a somewhat minor limitation where they can't cover that edge case of only one bug. Um, but yeah, I mean, cool research. It is fuzzing related, which we do cover quite a bit, but this touches more on the triaging and crash management aspect, which isn't really talked about as much and has been a pain point of fuzzing for as long as fuzzing's really been a thing. I would say. Um, One minor critique of the paper I have is I do wish it explained the metrics a little better, like the purity and burst purity and S score. I had to go out of the paper and do some like additional digging on my own to see what they were talking about there. It kind of makes sense that they would assume the reader would know what those terms meant given their target reader. I just think like a sentence or two on what those terms were defined as would have been really beneficial and made the paper a little bit more accessible. But yeah, other than that, like I think like their overall approach here was cool and
Yeah,
useful
I
too.
mean,
So
like I said, I think uh it's a good idea, to put it simply. Um, I will also mention that there will be a short, like, so this is a conference paper. The conference has not yet happened, so that'll be happening in November. It's from the SIGSAC, Computer Communication Security, CCS, which is happening mid-November. So there will be also a talk on it eventually, but we won't have that yet. We've just got the paper.
yeah, but yeah, other than that, that concludes most of our topics for this episode. We did want to shout out Deus Ex 64 from Ret to Systems. We meant to shout this out last week because that was closer to when they launched it. Um, we ended up accidentally skipping it though, so we didn't want to forget it again. Um, we've covered Ret 2 Systems quite a bit on this podcast, write ups from them and conference presentations. Well, we've mentioned the conference presentations. Um, they're just some really like smart and excellent people over there. So we wanted to shout out this this kind of war game that they put up for those who might not be aware of it already. I haven't gotten a chance to try it yet. I want to try to give it a shot this week, but I mean it's from Ret2 Systems, so you can be
Yeah,
pretty sure that it's going to be pretty good.
I have high expectations for it, despite not having gotten into it myself either.
Yeah, it's kind of like in the Project Zero category where it's like um, pretty much everything that they put out there is going to be worth checking out. So yeah, just wanted to shout that out quickly. Other than that, though, that's all of the topics we have for this week. Thanks to everyone who tuned in. You can catch the VOD on Twitch or on YouTube at 8 p.m. Eastern on Wednesday. We also have previous podcasts up on Spotify, Apple Podcasts, more links on Anchor. Feel free to join the Discord and follow us on Twitter. Links for those are down below for the video. I'll also put the Discord in chat for those who are in our Twitch right now. But yeah, that being said, we'll be back next Monday for our bounty episode at 3 p.m. Eastern, 12 p.m. Pacific, and next Tuesday for the binary episode at 7 p.m. Eastern, 4 p.m. Pacific. And we'll see you all next week.